What do wind farms, ships and silos have in common? They all require robust and reliable machines that shape steel, precisely, quickly, and in gigantic sizes. But who or what actually bends plate metal and shapes our infrastructure in so many different ways? For over 90 years, Swiss company Haeusler AG has been shaping steel for the major challenges faced by a wide range of industries. Over the decades, a small locksmith shop has grown into a global technology company, characterized by experience, quality and reliability, which now supplies more than 70 countries worldwide.
These were the real cash cows in the 1990s and 2000s, the longitudinally welded 12-meter pipes.
Were these entire installations? How large were they in terms of size? How much space did they take up?
About 500 meters, and then in 2 bays, each about 40 to 50 meters wide.
Wow.
Haeusler technology is actually everywhere we are, every day. In every boiler, in every tank, in airplanes. The dimensions of our machines are truly staggering. I can give you an example. A 4-roll plate bending machine that is capable of bending steel plates with a thickness of 330 millimeters. Those are massive dimensions. These machines are equipped with a force of around 10,000 tons.
Ready, set, bend. That's the moment when a plate metal part takes shape. But before that happens, the roll plate bending machines are manufactured here in-house, from the first screw to the last roller. Every step of the process makes it clear that size and precision are not mutually exclusive.
Our customers are in the wind energy sector, for example, where we build many machines. But we are also involved in shipbuilding, aircraft construction, and general plant engineering for the chemical industry. We start with a welded construction. We have metal sheets that are cut out and then tacked together. After tacking, they are welded to ensure stability. Then, the functional surfaces are milled on the milling machine. This removes chips. At the same time control cabinets are built, many parts are purchased, such as sensors, pumps, and motors, and then everything is assembled. After assembly, there is a commissioning phase where various functions are tested. With our machines, you can bend sheets of metal from 10 millimeters thin to 200 millimeters thick. These sheets can also be 4 meters wide. To manufacture our large components, you need a really large milling machine. That's why we have one of the largest milling machines in Europe, the Skoda machine. In order for the machine to operate with an accuracy of less than 1/10 of a millimeter, the surfaces must be machined with an accuracy of less than 1/10 of a millimeter.
All components are digitally designed in the engineering office, down to the smallest detail. Each machine can then be tested virtually using computer simulations.
Our development process to build a machine is completely digital. We run simulations. How does plate metal need to be formed? How is it constructed? What forces are required? What moments are needed? And so the mechanics, the electrics, the controls come into play. And finally, the whole thing is rounded off with the software, which is also simulated entirely with a digital twin.
The software you can see here is FEM. We can import the models there. Then we create a mesh over it and specify where the force is applied. And then we can simulate it. From that, we can see the stresses, which types occur, and how the component deforms.
If necessary, tests and trials will be carried out, but they have become minimal. We have become much faster and much less prone to errors than before. The Bendtronic control system has a large number of sensors. It records all data from the machine in real time and then corrects the positions live during the bending process, compensating for material fluctuations. This enables us to achieve consistent bending results and extremely high precision and quality. In recent years, we have developed to the point where we now apply the IKEA principle to special machines and single-batch production. This means that every screw is now planned, so that we can assemble the machine efficiently afterwards.
With its Bendtronic control system, the company is bringing artificial intelligence to metal processing. The innovative software technology analyzes material properties, simulates the entire bending process, and optimizes it in real time for fully automated, precise processes.
You enter the plate metal, e.g. with the dimensions thickness, width and length. Then you can target radii and program them. You can follow the entire process live on the screen. The positions of each roller are shown in real time, and you can track the CNC machine step by step to see exactly where it is working. The animation also shows the current state of the physical simulation, so you always know what stage the process is in. Our autonomous bending machines have a built-in camera and a radius measuring device. The camera ensures that the plate metal does not fall out of the machine, and the radius measuring device ensures that the machine can make appropriate corrections so that the bending result is perfect.
The engineering expertise of this family-owned company is utilized worldwide. Depending on the area of application, series machines or individually designed systems are created, developed according to the specific requirements of the customer. But global service does not end with the delivery. Through sustainable retrofit solutions, for example, the modernization of existing systems, employees ensure that machines and production processes remain operational, efficient, and future-proof in the long term.
The large bending machines we produce are mechanically designed to operate for 60 to 70 years. Over time, it's natural that not all parts needed to operate them will still be available, that technologies change, and that the introduction of new control systems, whether electrical or hydraulic, will upgrade the machines and bring them into top condition. The machines we build are so large that we cannot ship them in one piece, at least for the most part. That's why we have a strong service team that can assemble the machines on site and put them into operation. It can take up to 3 to 4 months to set up the machines in one location. Occasionally, there are also repair jobs where the technicians travel to the machines spontaneously, not knowing what they'll encounter. Anything can happen there. So the people who travel with the machine are real adventurers. We have also set it up so that we can maintain the machines or diagnose faults very easily via remote access. The bending machine is often the customer's main machine, without which they cannot function. And if the machine is down, then their entire production is down and help is needed. A family business like this naturally has the advantage and disadvantage that it holds old traditions and has old conventional ways of doing things. But each new generation of the family brings fresh ideas and a different perspective. This gives us new momentum for further development and sends a strong signal to our employees to incorporate these innovations into our machines. Hi, Anja.
Hi, Camille.
I'm going to see Jürgen and Elsbeth. Would you like to come with me?
Yes, I'd love to. I'll just finish up here quickly.
Yes, no problem.
Great.
How's your project going? Is it progressing?
Yes, it's going well. I'd like to use what I learned during my studies to help the company become more digital and make its processes more efficient, especially in business informatics.
I think that plate rolling technology will become even more automated. Bending complex shapes will certainly become more important. The bending of very expensive alloys, which must be done with great precision, will certainly play a greater role. And then we will see what else the future holds.
A true hidden champion that shapes the world with experience and Swiss precision. But what really counts here goes beyond technology: trust, consistency, and family values.